Is it me, or does anybody else have difficulty understanding quantum mechanics? This Higgs thing is fantastic, isn't it? It's absolutely marvellous that they've managed to discover this thing, and the money that's been spent on that CERN Hadron Collider, or Hard-on Colluder as it's been misquoted in the press. I thought that was hilarious. But yeah, it's absolutely fantastic. And I tell you what, I'll put the URL down the bottom here on the description. There's a fantastic video by Professor Brian Cox. He did an hour-long thing with all the celebs last Christmas about quantum mechanics, and it was really interesting, and it's well worth a look for the layman. But I can't really get my head round some of the propositions. Are a bit beyond my capabilities, to be honest with you, a bit beyond my understanding. It's and I don't mean the number crunching. Obviously I don't understand the number crunching, but some of the propositions are, I just find them difficult to swallow. But yeah, that Higgs thing was really great. It was lovely to see old Higgsy boy was there as well. That's really fantastic, isn't it, that he's managed to survive long enough to see his thing come to fruition. And old Stephen Hawkins suggesting he gets a Nobel Prize. Well, yeah, I agree. Good luck to the bloke. He ought to. And yeah, so I said, as I understand it, it's supposed to be the particle that gives matter mass, isn't it? Because it's interesting, isn't it, the old history. Like when my old man was being taught physics and all that, he was, it was matter can neither be created nor destroyed. And had old Einstein and his theory of relativity and the atomic bomb to show that, that matter was destroyed and then destroyed to energy through E = mc squared. But I don't know. Is it supposed to be? I don't know. Does the matter, when it's destroyed by by a nuclear reaction, does it go into all these subatomic particles? So in effect that hypothesis or theory does stack up, that that matter isn't destroyed, and it's just that we weren't measuring it because we were looking for mass in its normal sense, as it were. Or does it energy plus all these subatomic particles when it goes boom, or or is it actually destroyed? I don't know. Anybody who wants to answer that, just add on the comments list below. But we had that, and and then we went on and on to this unified theory or whatever it is, but there's some of it that really gets me. The thing that really I find impossible to get my head around is they reckon this video that I'm talking about, Brian Cox, it kind of comes to nearly towards the end of this, and apparently he's also got it in his new book as well, which I'm going to read. My old man's bought it, I'm going to read it and pinch it off of him. That when with the old model of the atom, of the electrons are so far away from the nucleus, it's like the example that he gives, I think, is a bloke sitting on the White Cliffs of Dover, then and was the nucleus of a hydrogen atom. Then the electron was something like a pea somewhere in central France. That's where the electron shell, the highest density of the probability of the electron shell would be, and that would be the kind of size difference. And then they go on to say this, and I find this absolutely. This is where I start to think, are they making it up? Or not making it up's a stupid thing to say, but are they a bit blinded by the maths and losing a bit on the old common sense front? Because what they're suggesting is, as I understand it, if one electron in one atom changes its energy state, then every other electron in the universe, mark you, in the universe, right, apparently simultaneously has to change its energy state to accommodate it. It's just, there's trillions of atoms just in me, sitting here talking to you. hang on. So, well, another thing then, tell me this then, here's a bit of conjecture here for you. If we are to assume that nothing can go faster than the speed of light, which is what they are all suggesting and have been suggesting, and they poo-pooed that thing that happened at CERN the other day, didn't they, and found that all the results were wrong, and the fact that it is the case, it would appear that nothing can go faster than the speed of light at the moment. And apparently all these electrons all juggle themselves about once one of them's moved, and there is distance between them. That's the point. They're not all crammed together. You could perhaps understand a kind of, shuffling over if each one touched each other. But you've got to bear in mind, the old White Cliffs of Dover and Middle of France analogy. There's more space in the universe by a huge amount than there is actual stuff. One of these electrons moves. How does it communicate with all the other electrons in the universe instantaneously if there's nothing can go faster than the speed of light? See? I mean, they're suggesting nothing go faster than the speed of light. Well, across our galaxy is 40,000 light years from galactic central point. We go round every 300 million years. The old Eric Idle song from... I learn all my physics that way. From what was it called? Meaning of Life. What a brilliant film that was. But there's whatever it is. We're 40,000 light years from galactic central. I mean, that's the sort of thing we're talking about. The distances, light years, 40 years at the speed of light. That's the distance. If you travelled at the speed of light, it takes 40 years for us to get. And that's just our galaxy, and we're not at the edge of that. Then there's intergalactic spaces are absolutely vast, and they're trying to tell me that one little hydrogen atom inside me, say in one of the water molecules in my body, because I'm speaking to you now and starting to froth at the mouth, one of the electrons moves in its shell, and every other electron in the universe shuffles about instantaneously. Well, I mean, it's a bit of looking at it with a bit of common sense, isn't it? It's just, I don't know, way beyond my capabilities of understanding that. And I don't wish to be rude, but you're not really. There just can't be any logic behind that, surely. Or am I just putting human emotion and human inability to understand the goings on of the universe? The human mind is incapable of understanding. Perhaps that's the case. It's absolutely beyond me. And I don't know. It's just, I'll tell you what was another interesting one that shed a lot of light on things for me was they had a program where they had all these television physicists, Brian Cox and that old Professor Alkalini. Good, I like him. He's good. He's and the old mathematician Sayuto or whatever his name is, and they were going on about the fact that that now that they've established the fact that black holes are a very common thing, and every galaxy revolves around a massive black hole, that they're all a little bit egg on their face because they don't know where to go, because neither the theory of general relativity or quantum mechanics stack up. The numbers don't stack up as you approach the event horizon. So they're a little bit boxed there, as the saying goes. Well, who knows? Maybe maybe all these new discoveries at CERN will help them unravel it all. It's all beyond me, though, I have to say, and there are a few bits that, at the end of the day, I think they just seem to lose a little bit of common sense along the way. I know it's all mathematics, and they stick it all down on paper, and they put all these wonderful symbols in front of things, and deltas and sigmas and all this stuff, and say, look, it can't not be true, because we've managed to stick it down in numbers. Yeah, okay. But, a little bit of rationality sort of come into it here and there. But anyway, it's a good day, isn't it, for for science, and as well, I love it, all that stuff, and I love all that money being spent. All that. Having said that, you know, there was a fantastic thing the other day on Facebook. This happened to be picking on the Queen, which I don't necessarily agree with, and I don't necessarily agree with what I'm about to say for the Surname Collider, but it does sort of make you think. They had a picture of the Queen in all her finery and dripping with diamonds and, you know, all the usuals. I'm not a royalist, you know, I agree with monarchy. It does a good job, as you can hear from the last rant that I've just done, if you want to listen to it. But they had a picture of the Queen all dressed up in her tiara and pearls here and Christ knows what. Then underneath it said, meanwhile, ... and the picture below is those poor little blighters in Africa, you know, the little kids starving to death. I suppose, you know, and I thought, yeah, it's good. Not necessarily a good for the Queen, but you know, you could say the same thing about the billions and billions of pounds being spent at CERN. Is there actually any point in it? But I think so, you know, the advancement of human understanding is really important. But there you are. But some of this quantum mechanics is well over my head. Mustn't grumble, eh? Hurrah.